Okay, so as in the last video, we have done a numerical, right, of finding equivalent capacitance. We got to know that the equivalent capacitor or the reciprocal of equivalent capacitor would be equal to the sum of reciprocal of all individual capacitors when they will be connected in a series. Series means when they will be connected in the same path, right? Now today we are going to start our new topic, which is basically capacitors in parallel. We have completed our capacitors in series or series combination, right? Today we are going to discuss the parallel combination or capacitors in parallel. So let me write the heading here. What we are going to discuss today is parallel combination, 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 or capacitors in parallel, right? Capacitors in parallel. Let me highlight this topic. What we are going to discuss today is parallel combination or capacitors in parallel, right? So I'll be telling you what does mean by parallel. As I told you when we were discussing the capacitors in series or series combination, I told you the meaning, right, by making a diagram. So here I'll be making a diagram as well, so that I can make you understand by help of that diagram. So let me make the diagram here. This is basically a battery, positive terminal, negative terminal, right? Right. Here we have one capacitor. Here we have another capacitor. And here, of course, I have another capacitor as well. Right? So this is C1, this is C2, and this is of course C3. Right? When we were discussing in series, we made in the same path, right? All the capacitors were connected in a same path. As we are now discussing about the parallel combination or capacitors in parallel, now the capacitors would not be in the same path. They would be parallel, right? As you can see, one is in this path, second is in this path, third is in this path, right? Here basically we have a potential difference called A. Here we have a potential difference called B, right? And here we have provided it with a potential difference or V volt, right? This is basically positive terminal of the battery. Positive terminal. This is basically negative terminal of the battery, right? And this is C1, this is C2, and this is C3, and these are the capacitors. In series they were connected in same path. However, in parallel they aren't connected in same path, right? Their path is different. Their path is different. Last one. Right? So C1, C2, C3, they are connected in a parallel, right? So when they will be connected in a parallel, the same potential difference would be provided to each plate of the capacitor, but the charges stored on the plate of the capacitor would be different, right? So they will gonna store the same potential difference V volt. However, the charges which will be stored by these capacitors would be different, right? So this will store Q1 because this is C1, right? This will store Q2 and this will of course will store gonna Q3, right? So now what's the definition of it, right? Consider three capacitors C1, C2 and C3, or no, we are not considering it first, right? We should discuss about the parallel combination first, right? When two or more capacitors are connected in such a way that positive terminal of a battery connected to one end of common point. Now let me show you that common point, or let me write the definition here so that it would be easy for me to explain you with that definition, right? So when two or more capacitors are connected in such a way in such a way the positive and, or you can say the positive terminal of a battery connected to one end of to one end of common point and other end of each capacitor are connected to negative terminal of a battery. Such type of combination is called parallel combination, right? Or capacitors in parallel. Combination, or you can write capacitors in parallel, right? Now see, read the definition and understand the diagram. When two or more capacitors, here basically two or more, which means two or more than two, right? So we are taking three capacitors, right? When two or more than two capacitors are connected in such a way, means if three capacitors or more than three, you can also take more than three, right? This is not a limit that you can only take three. You can take four, you can take five, six, seven. There is no any limit of taking the capacitors, right? When two or more means we are taking here three, so I'm using here number three. When three capacitors are connected in such a way so that the positive terminal of a battery connected to one end of a common point. Now see, this positive terminal of a battery is connected here with one common end, right? This is one common end which we have given name as A, right? And other, now see, and other end of each capacitor are connected to negative terminal of a battery. And now see, these are other capacitors, right? Other capacitors, and they are connected with this point, and this is connected with the negative terminal of the battery, right? This such type of combination is what we call the parallel combination, or you can say capacitors in parallel, or you can say capacitors in parallel, either parallel combination or capacitors in parallel. Again, what did I say? When two or more capacitors, which means when three capacitors are connected in such a way, the positive terminal of battery is connected to one end of common point. This is the one end of common point, right? And Now see, and other end of each capacitor are connected to negative terminal of a battery, and each end of a capacitor is connected to one common point, and that is connected with the negative terminal of the battery. Such type of combination is what we call the parallel combination or capacitors in parallel. In the next video, we're gonna consider these capacitors, and we're gonna see what will be same in the parallel and what would gonna be different, right?